Hello everyone. Today I will teach you chapter number 15 of class 8 NCERT Maths. The name of this chapter is Introduction to Graphs. Okay? Now let's start.
You look lost, Snail. What are you thinking?
Oh, hi. I'm thinking about our phone bill.
What happened? Was it high this time also?
Yes.
Oh, your dad must be really upset, huh?
Yeah. In fact, he has strictly told all to talk less on phone.
Of course. The less you talk on phone, the lesser will be your phone bill, and vice versa. Hey, there's a linear relation between them. You know, you can represent such linear relationships on graphs. These graphs are nothing but linear graphs.
Breathe, Miss Marks. Math is making you too fast. Now, what's this linear graph?
Recall, Snail, a linear graph is a whole unbroken line.
I seem to recall a little.
Oh, Snail, before you annoy me further, let's see some examples of common linear graphs today in the virtual world. Let's begin the module with this illustration. New York is about 12,952 kilometers away from Mumbai, and it takes 16 hours to reach there by a non-stop flight. Is it possible to know how far one would travel each hour? If we assume that the Mumbai-New York flight is non-stop and flies at a constant speed, then distance-time graph can help us know that. Wondering how? Let's find out in this module on linear graphs, where we learn to plot some specific linear graphs like distance-time graph, quantity versus cost graph, and finally, principal versus simple interest graph. In distance-time graphs, time, being independent variable, is taken on the x-axis or horizontal axis, and distance being dependent variable is taken along y-axis. The total distance of 12,952 kilometers is covered by the non-stop flight in 16 hours. Assuming that the flight moves at a constant speed, the flight approximately covers 810 kilometers in an hour. So in 2 hours' time, flight will travel 810 plus 810 is equal to 1620 kilometers. In 3 hours' time, it is 2430 kilometers, and so on. We can make a tabular column where we list this distance-time data. On y-axis, mark the distance using a scale of 1 unit equal to 810 kilometers. Appropriately, along x-axis, each unit can represent 1 hour. Now plot the points. 1 hour, 810 kilometers. 2 hours, 1620 kilometers. 3 hours, 2430 kilometers. 4 hours, 3240 kilometers. 5 hours, 4050 kilometers. And 6 hours, 4860 kilometers. On joining the points thus plotted, a straight line or a linear graph is obtained. Straight line between distance and time implies that these two quantities, distance and time, are in direct variation. For example, at 2.5 hours, the flight would have traveled through 2025 kilometers. Similarly, at 5.5 hours, the flight would have traveled through 4,455 kilometers. Hence, we can employ the distance-time graph to predict the distance traveled by a body moving at a constant speed at a given instant of time.
Wow!
Why are you laughing?
I am thinking there is a linear relationship between the food I eat in the canteen and the bill I have to give. I can plot that on a graph too.
You're right, but that's not funny, Snail, huh? Anyways, let's go to the virtual world and see another example of linear graph. It's a common experience that more the quantity one wants to buy, more one has to pay. This logic holds true for any commodity available in the market, be it sweets, books, or anything. Mama has bought apples. She paid rupees 100 for 1 kilogram of apples. She was told by the fruit seller that there is no discount on the price of apples, whether she buys 1 kg or 10 kgs of apples. So for 2 kg of apples, the price will be rupees 200. For 3 kgs, it is 300, and so on. In this data, the quantity of apples is the independent variable and price is the dependent variable. So, while we plot the graph between quantity versus cost, we can represent the cost on the y-axis using a scale of 1 unit equal to rupees 100 and the quantity on the x-axis using a scale of 1 unit equal to 1 kg. Plotting the points 1, 100, 2, 200, 3, 300, so on. And then joining them gives straight line graph between the quantity and the cost of apples. From this graph, as we did earlier, for any given quantity, we can know the total cost of apples or vice versa. It appears to me you're not in mood to study today,
No, I am.
Okay, then tell me what's the relation between simple interest and principal?
That's a tough one. I wanna learn.
Okay, then let's learn that in the virtual world. Bank deposits are considered to be safest form of savings. We earn simple interest on the principal amounts invested in the banks. Recall the relation between amount invested and simple interest earned. It is SI is equal to PRT upon 100, where SI is the simple interest, P is the principal amount, R is the rate of interest, and T is the time duration for which the amount is deposited. Clearly, the two quantities SI and P are in direct proportion. For a deposit of 1 lakh and above, the bank offers 11% simple interest per annum. So, if the amount is 1 lakh, then the amount of interest earned will be 11,000 rupees in a year. For an amount of 2 lakh rupees, interest earned would have been rupees 22,000 and so on. Now, in order to plot the graph between SI and P, principal amount P is taken on the x-axis and the simple interest SI is taken on the y-axis using. On plotting the points 1 11,000, 2 22,000 and 3 33,000 and so on, and joining them, the simple interest and principal graph comes out to be a straight line graph. Thus, it's possible to find the cube root of a given algebraic expression.
Plotting graphs makes things so easy.
Right, Snail?
I was wondering whether these graphs go under algebra or geometry.
Well, this is algebra only, but in higher math, there is a special branch of math called graph theory. There is an interesting story behind the foundation of this branch.
Story? I love stories.
Great. Then let's check out in the Do You Know section. Do you know that a problem related to a city named Königsberg in Germany laid the foundations of graph theory in the year 1735?
How?
The city is built around the junction of two rivers. 7 bridges were built to connect the parts of this city on both sides of river for people's commutation. Some people tried to discover a path through the city which would cross all 7 bridges only once but never succeeded. Later on, this problem came to the notice of Swiss mathematician Leonardo Euler.
So, did Euler find the path?
Well, he simplified this problem by representing each landmass as a point and each bridge as a line, and ultimately concluded that the problem had no solution since each landmass has odd number of edges. While doing this, he laid foundation of what is now called graph theory.
Oh, that's amazing!
Now why don't we take quick memory jog and revise everything we have learned today? In this module, we have learned the following. A line graph, which is the whole unbroken line, is called a linear graph. A linear graph can be plotted by taking the independent variable on the x-axis and dependent variable on the y-axis. Two quantities which vary directly can be plotted as a linear graph. A linear graph can be interpreted to find out the relation between two quantities.